Hello everyone, welcome. Today topic is stock market price prediction using machine learning. In this video, I am going to explain our topic with an example source code. Before going to start, don't forget to subscribe our channel and click the bell icon for more interesting project videos. We have developed this project in Jupyter Notebook. So here is our project. Stock market price prediction using machine learning. So these are the libraries we want to import them. So first one is math. Math module provides access to the mathematical functions. Next, import numpy as np. Np just an alias. Numpy is a Python library used for working with arrays. Next, import pandas as pd. Pandas also a Python library, provides high performance data structures and data analysis tools. Next, import seaborn as SNS. Seaborn is a Python library used for making statistical graphics. Next, import matplotlib.pylab as plt. Matplotlib is a multi-platform data visualization library, and Pylab is a procedural interface to the matplot object-oriented plotting library. So next, from sklearn pre-processing, import min-max scalar. Sklearn is the short form of scikit-learn. The sklearn library contains a lot of efficient tools for machine learning and statistical modeling. So from the sklearn, there is a pre-processing family. From that family, we import min-max scalar like this all. Next, from sklearn.model_selection, we import train test split. From sklearn.ensemble, we import random forest regression. From sklearn.matrix, import mean squared error. From sklearn.preprocessing, we import label encoder. Train test split random forest regressor, we will see the definition later. The last one is percentage matplotlib inline. The percentage matplotlib inline sets the backend of matplotlib to the inline backend. So the label encoder. Label encoder used to transform non-numerical labels to numerical labels. So okay, these two definitions we will see later. Next, load the data. So here in the pandas, there is a read_csv function. This is used for load data. Okay, we store this data in df. So in the input folder, our stock_data.csv file is there. So next, header is equal to 0. Header is equal to 0 means you have the names of columns in the first row in the file. Okay, just now we call this df.headof means headof function is will provide the first 5 rows. Okay, so in this statement df.shape means the shape of df. So we printed here 1259, 7. It means we have 1259 rows and 7 columns. See, the 7 columns are date, open, high, low, close, volume, name. Next, data pre-processing. Here we need only DPS, it's a company. This DPS presented rows only be enough, so just we printed the list of DPS. So next df dot data types means we check the data type of columns. See, date, open, high, low, close, volume, name, these are our columns. These are the data type of the columns. See, date, object data type, open column, float 64 data type, like this. So we want to change the date data type. So if the date data type is object, we will face some problem. So for that only, here we changed date data type object into date time data type. So done. Next, so the process, we just printed or we just display, we want to DPS presented rows only, because that is our task, DPS presented rows only. So here is in the open column, is any null values presented or not, we are checking here, and we stored this value into company underscore df. So next, using company underscore df, we checking is any null values are presented or not in the whole columns. Say in the date column there is no null values, open, high, low, close, volume, there is no null values in the columns. So next, if any null values presented, actually there is no null values, if any null values presented, we want to drop them, means we want to remove them. For that purpose, drop NA of function used. Axis is equal to 0, comma in place is equal to true. Axis is equal to 0 represents the rows, axis 1 represents the columns. So in place is equal to true means it will delete permanently. So without in place is equal to true, we can't remove permanently, we can remove temporarily. So see, this is the company, all after this all the process, company underscore df has this kind of data set. And next, data visualization. So by using these columns, here we printed some plots, our needed plots. Next, we separated open, high, low, close columns only, because these columns only have numerical values. And then we changed date column into index for our own purpose. So this is the date column into index statement. So next, we need x and y values. So we store our class, means close column, we will store in y in the y. So without close means without class, we will that values we will store in x. Okay, axis is equal to 1 means it represents the columns. So class value stored in y, so without class values stored in x data. So this is our y values, this is index, this is y values. Next, data split. So in the data split, we use a train test split of function. Train underscore test underscore split of function used for splitting data arrays into two subsets. See, x train, x test, y train, y test values are printed here. So 880, 3. This is the values of x train, which means for the x train purpose, we separated these values, 880 rows and 3 columns. This is x test 880 rows and one column for X test purpose. For Y train purpose, we have 378 columns, 378 rows and 3 columns. Next Y test, 378 rows and 1 column. Okay. Next, random forest regressor. So random forest is an ensemble technique capable of performing both regression and classification tasks. Here we using random forest technique for regression task. So y underscore true is equal to y test. So we giving the y test values. Y underscore prediction is equal to we give y prediction values. So see, forest dot predict x test. We predicted the shape of the x test. 378 comma 1 means 378 rows and 1 column. So next, mean squared error. Mean squared error of an estimator measures the average of error squares. So this is the average of our error squares, 0.1765 something. So next, R2 score for the test set. R2 score is used to evaluate the performance of a linear regression model. In simple words, it's a statistical measure of how well the regression predictions approximate the real data points. See, 99.94%. Good. So next, y test values, y prediction values. So here we check the data type of y test, float 64. Here we check the data type of y prediction. This also float 64 data type. So next, visualization. By using this data, predicted and actual data, we plotted one chart for our understanding. So next, another one bar chart also we printed using this actual and predicted values. So guys, this is our project. Thank you for watching.